Hello video viewers, fellow scholars. This video was made to introduce a paper I presented at AIPE 2021, the second international conference on artificial intelligence and power engineering. It's my honor to attend the conference and I wish the conference a successful conclusion. Now let's begin my presentation. The title of this presentation is The Evolution Index System of Electric Power Industry Supply Chain Management based on FAHP. The author is Xia Zhenlai, Zhou Ruyi from Energy Development Research Institute, China South Power Grid, Zhang Guangxiang, Zhong Huilin from the Department of Electric Commerce, South China University of Technology. The presentation will consist of the following 5 parts. Part 1, Introduction. Background: social change brought by digital technologies. With the continuous development and upgrade of the modern supply chain, electric power companies increasingly require the supply chain management system to the scientific, systematic, and coordinated. The Supply Chain Management Evolution Index System is a key means to accurately analyze the supply chain management and development. The evolution content of the electric power industry supply chain management evolution index system should meet the demand characteristic of the electric power industry supply chain, be scientific and effective, and be consistent with development requirements of modern supply chain. That is, highlighting the characteristic of planning, transparency, real-time collaboration, and intelligence of the supply chain. In order to paint the guide role of supply chain management evolution, in order to play the guiding role of supply chain management evolution, therefore it's essential to establish an evolution index system suitable for the modern supply chain management in the electric power industry. At present, the research of the evolution supply chain management in the electric power is mainly from a practical, partial perspective. It's not comprehensive. The second, supply chain digitalization is not mature enough, and digitalization indicators are seldom mentioned. The concept of green development, which is often ignored by supply chain performance indicators, is an important direction of supply chain. Many systematic evolution on the entire supply chain business management in other industries were put forward, but few apply to the power industry. That's the limitation of existing relevant research. Based on the existing research, this paper proposes a QBENS evolution index system for supply chain management in the electric power industry. In a different way to foregoing literature, this evolution index system includes a range concept of modern supply chain, such as a digital supply chain and green supply chain, and comprehensively describe the overall operation and development level of electric power industry supply chain through the evaluation of the 5 demands of quality, efficiency, benefit, norm, and service. The index weight is determined by FAHP, which ensures the scientific and regionality of the index wave, and a variety of scoring methods are used to score the indicators. Through case study, it can be seen that the evolution index system can help electric power industry managers find problems in the operation of the supply chain, improving them in a timely manner and guide the supply chain to develop a better direction. The second part is construction of QBENS index system. Uh, Now I will introduce the related supply chain evolution index system. Like SCORE, SCOR means Supply Chain Operation Reference Model. It's a process reference model as the cross-industry standard diagnostic tool for supply chain management. BSC is Supply Chain Balance Scorecard. It measures the effectiveness of management from four perspectives: finance, customer, internal operation, and learning and growth. DDVN is Demand-Driven Value Network. The model gives 5 stages to tell the supply chain manager how to evaluate the company's current supply chain status. QCDS model evaluates suppliers from 4 aspects: quality, cost, delivery and service. In addition, the electric power industry has unique demand characteristics compared with other industry supply chains. Now I will introduce 4 management objectives of electric power industry supply chain. First is resource guarantee. It amplifies the premise of qualified material quality and ensure the whole process service of material selection, procurement, quality control, and final link. Value creation. We need to pay attention to the overall utilization of resource achieve full cycle management of materials, achieve cost reductions, and gain of supply chain. Digital operation amplifies digital operation amplifies the synergistic operation efficiency of all links of supply chain management, improve the speed and efficiency of supply chain operation and creative benefits. Risk control, comprehensive risk prevention and control in quality, price, possible supply interruption and public health events. So based on the measurement objective, we created the QBENS index system. The quality dimension Q mainly evaluates the level of material and quality management in the electric power industry. Relax the supporting role of resource guarantee at the strategy level. The benefit dimension B mainly examines the cost of the supply chain and financial related process links of the electric power industry. Reflects the level of value creation at the strategy level. The efficiency dimension E mainly measures whether the operation of each link in the electric power industry supply chain is efficient, reflects the effectiveness of digital operation at the strategy level. The non-operative dimension N mainly evaluates the companies of the various process of the electric power industry supply chain and the social responsibilities assumed reflects the status of supply chain risk control. Service. The service dimension X mainly examines the satisfaction of internal customers in the supply chain of the electric power industry with the supply of materials as well as the satisfaction of cooperation with external partners. Starting from 5 dimensions, construct the electric power industry supply chain evolution index as shown in this figure, which contains 32 indicators, all certified by experts to ensure their applicability. The elevation index system completely covers the main activities of supply chain management in the electric power industry, comprehensively reflects the overall operation level of the supply chain, includes the concept of green supply chain, like green packaging category coverage, considering the planning, transparency, real-time coordination, wisdom, and other characteristics of digital supply chain, like remote supervision radio, and give full play to the guiding role of supply chain management evaluation. Part 3 is the confirmation for evaluation method. This paper used FAHP analyzed hierarchy process to determine the index rates. The FAHP analyzed hierarchy process determines the index rates according to the 3 steps. Step 1 is the construction of the FAHP consensus decision matrix. The FAHP consensus judgment matrix R is an M times M matrix. Is obtained by expert scoring and other methods and obtained through the operation of statistical experts. Its elements Rij have the following properties. Step 2 is to calculate of the weight of each secondary index. The weight of each index of FAHP analyzed hierarchy process is obtained by matrix calculation, so as to determine the relationship between the hierarchical index and calculate the higher level index. The calculation method of the secondary index weight Wi is based on this formula, where n is the number of the index. This paper takes the resolution parameter beta is this formula. Step 3 is Step 3 is determination of comprehensive evolution score. Due to the different development scale goals and characteristics of each electric power enterprise in different regions, the indicators cannot be compared horizontally. So, this paper used different scoring methods for different secondary indicators, such as internal distribution method, index compliance method, increasing the decrease comparison method. The dimension score B simplifies is carried out by multiplying and additing operator through this formula. In the formula, D is one of the 5 dimensions, and R represents the scores of the X secondary index under the dimension. Part 4 is case study. This paper selected 2 branches of a large power grid and enterprise in the regions A and B as the analyzed projects. We collected the data in the first quarter of 2021. Abundant branch A is located in a more developed area and the scale of supply chain is larger. Branch B is located in a remote province with a smaller scale of supply chain. So this is the 3 steps of the evolution process. Step 1, is the construction of fuzzy consensus decision matrix. Taking the quality dimension index as an example, we get the RQ similarity. We can get the whole index system. R is the scale is 32 times 32. Step 2, we calculate the weight of each secondary index, and we get the weight of the whole index system in table 1. From the table, we can get that the quality, benefit, efficiency, norm, and service takes this percentage, and each secondary indicators takes the percentage like as shown as in the table 1. Step 3 is the determination of comprehensive evolution scope. According to this formula, the scale of each dimension and the comprehensive scores of the 2 regions are as follows. We can see from table 2, branch A gets gets 85 comprehensive scores, and branch B gets 83 points. So now let's analyze the scores the 2 branches get. Based on the actual situation, the operation situation of the power grid supply chain in the 2 regions are analyzed through the above-mentioned evolution index system. We can get these 4 conclusions. The supply chain of branch A has efficient operation and maintenance and a high degree of standardization, providing high-quality internal and external service. But at the same time, we can see the failure of branch B to exert its scale offer because the benefit score of branch A is only 64, is too low. Branch B should consider increasing capital investment, strengthening supply chain construction, and improving supply chain guarantee capabilities. Because in branch B, the quality, efficiency, and norm, the 3 parts is not perform well. Specifically, managers can elevate the process of the current digital transformation of the supply chain according to the secondary digital indicators, optimize management measures, and better practice the green supply chain development concept according to the green indicators. In summary, The scores of each dimension of QBENS index system can be objectively reflects the current situation and development level of power industry supply chain management in different regions to a certain extent. Accurately identify the defects of the supply chain, help to further strengthen the management of orientation and drive the innovative development of digital supply chain in power industry. The last part is summary. Starting from the development requirements of modern supply chain, this paper constructs an electric power industry supply chain management QBENS evolution index system based on 32 indicators in 5 dimensions of quality, benefit, efficiency, norm, and service. This system can fully reflect the business of electric power industry supply chain. The system combines the characteristics of digital supply chain and the development concept of the green supply chain, which is forward-looking and advanced. Through the actual application of a large power grid company in China, the FAHP is used to set the index rates and the branch supply chain management of different regions is evaluated and analyzed, which prove the feasibility and effectiveness of QBENS evolution index system in the practical application of the electric power industry supply chain management. That's all of my presentation. Thank you.